Today's lesson is lesson number 79. We're going to continue talking about solving quadratic equations. Today we're going to kind of put everything together. So we're figuring out which is the best method to solve. If we're given a quadratic equation and it just says solve for x or solve for n, we want to know, okay, what approach do I take? What's the best strategy here? That's what we're talking about today. Okay, are we ready to move on to the steps up here on the big screen? Not quite yet, okay. All right, so for strategy, first thing you want to do here is always look for the GCF, okay? No matter what, remember we're trying to have it something equal to 0. If we want to factor it maybe somehow, and we're able to set each of those factors equal to 0 then. So that would be finding the GCF or using difference of squares, taking a square root. After those three, maybe we move on to something like Xbox or trying to complete the square, using the quadratic formula, and then finally we could graph. We could always graph and look for the intercepts. Okay, so just some notes here. For 2 and 3, you want to make sure that it's in this form if you do difference of squares or taking a square root. Okay, so difference of squares or taking a square root, you can't have a middle term. Okay, so you can't have something that just has an x. You have to have just something with an x squared and then just a constant equal to 0. That gives you, once you have that, then you could do difference of squares or taking a square root, okay? So if you don't have that, if you have a b term in there, then you're going to want to move on, check something like Xbox, or you could do completing the square, or quadratic formula is kind of like the go-to. It will always work, but it's not exactly the nicest, cleanest way, but it'll get you the answer, okay? Right, it has that square root in there, so sometimes we don't like using that, but it will give you the answer. If you use Xbox and you get not factorable, that's not the same thing as no real solutions, okay? So that just means that it's not an even, it's not like 2 and 4, 5 and 7, okay? It might be like plus or minus the square root of 13, right? You wouldn't be able to find that from Xbox. You need to use a different method. Okay, so not factorable just means that it's not the right method to be using. It means you need to move on and use one of these. And then graph, we kind of just want to use if it's already in vertex form. So if it looks something like this, for example, you would want to graph then. You set that equal to y, and then you're looking at where it intersects the x-axis. That's where it's equal to 0. Okay, so go ahead and make sure you have these written down, and I would add these little notes in so that you know. Up to you, though. All right, so 1 and 2, I want you to listen for the strategy that I'm explaining to, not just watching the steps, okay? So pencils down right now, and you're focusing up here on 1 and 2. Okay, so number 1, the first thing I want to do is set this equal to 0, okay? I get a much better picture when I can clearly see what A, B, and C are. That gives me a better idea of how I want to move forward. So I'm going to subtract 4 from both sides to get this equal to 0. Okay, the 4's just cancel out then, so I have k squared plus k equals 0. So I think, that's interesting, right? The constant canceled out. So I have a k squared term and a k. So those both have something in common, right? So I'm thinking, oh, hey, I have a GCF now, right? It's not a number, but it's a variable, right? They both have a k in common. So I know the GCF is k. So I'm going to factor that out. Okay, when I do that, I divide each of these by k, right? I factor it out, divide each of them by k. So k squared divided by k is k. K divided by k is 1. Now I have two things being multiplied together that equal 0. Remember we talked about the only way that's possible is if one of those things is 0, right? 10 times 2 gives me 20. 1 times 5, I have 5. I can never get 0 by multiplying unless I have 1 times 0 or 0 times 5. Right? I need a 0 in as one of the factors there. So I get to split this up then using that property. So I have k equals 0 and k plus 1 equals 0. Okay, then my first equation's already solved for k. I already have k equals 0 as one of my solutions. And then in the second equation, I subtract 1 from both sides. And I get k equals -1 as my other solution. That one's so easy, yeah. Not bad at all. Not exactly. This could be a problem though, right? And you could solve that really easily. So those would be my two solutions. Okay, the more important thing here is to think about which is the best strategy. We should have already learned all these different methods. We have practiced all of them, but now we're just thinking about which is the best way to proceed here. So number 2, I'm going to start again by just moving that 26 over this way so that I have it equal to 0. So I'm going to subtract 26 from both sides. Oh, sorry. Also, I realized there's no n term, right? I don't have like plus 9n. I just have an n squared and I have constants. So I'm thinking number 2 and number 3 on my strategies may be a good way to proceed. Okay, so I'll rewrite this. This is 81n squared. And then when I move the 26 over, when I subtract it, I can combine it with the 1, right? So 1 minus 26 gives me -25. Okay, then I know that 81n squared, that's a perfect square, right? 81 is 9 squared. And then n squared is squared, obviously. And 25 is a perfect square as well. So, and there's a different subtraction sign between them, right? So difference of squares. I separate these by thinking, okay, that's just 9 squared times n squared. That's 5 squared. I take the square root of the first one and put it at the beginning of each set of parentheses. I take the square root of the second one. I put it at the end of the parentheses. And then one's positive, one's negative. Okay, remember this was our difference of squares pattern back in factoring. Okay, you also could use an Xbox here. You would just have to remember that b is 0. Okay, so that's important when you're plugging in those numbers for your Xbox. Once I'm here, I have a product equal to 0 again, so I can split it up using the 0 product property. So I have 9n minus 5 equals 0, and 9n plus 5 equals 0. I can then add 5 to both sides here, and then I divide by 9. So I get n equals 5/9 for my first answer. Over here, in this second equation, I start by subtracting 5 from both sides. That gives me 9n equals -5. And then I divide by 9 and get n equals -5/9. Okay, so those would be my two answers there. And again, difference of squares was the best strategy to use here. Okay, and the answer, again, you can write as plus or minus for number 2 if you want to shorten it that way. Okay, then for number 3, we have this equation, and I asked the students which method would be best to start here. Since it's in vertex form, we would want to use the last method, which was to graph. So if I graph this, I'm thinking, okay, this is vertex form. So I know h comma k is going to be the vertex, so that means my vertex is 2 comma -2. Okay, so that's this point here. And then I know my a is negative, so that tells me that the quadratic is going to be facing down. Okay. Since it's facing down, no matter how wide or narrow it is, I could graph this exactly, right? I could make the little table, but really, it doesn't matter how wide or narrow it is. It's never going to hit the x-axis here, so it's never going to be equal to 0. So this is just no real solutions here, okay? Again, here's an example of even if it was wider, it's still not going to hit, so no real solutions. Okay, and then for number 4, we're looking at, we first want to move the 3 to the other side so that I have one equation, right? I can really look at what A, B, and C are. There's no GCF, so I can't do that. Then I move on to the second and third strategies. Both require that I don't have a middle term. So I can't do those. Okay, again, if I'm trying to do difference of squares or taking a square root, I can't have a number here. So I skip those. I could do Xbox. I could try Xbox, but if you try that, you would see that I can't factor the 87. So I can't factor the 87 in a way that would add to 4, so Xbox isn't the best way to move forward here. The next thing I would want to try is either completing the square or quadratic formula. Either one would be fine here. Here is what you would get if you use quadratic formula. Okay, so I would have k equals negative b, right? So negative 4 plus or minus the square root of, this is 4 squared, or b squared minus 4ac, all over 2a, and a is just 1, so it's just all over 2. Okay, then I'm going to simplify what's in the square root. 4 times 1 times 87, that's going to give me 348. So I have 16 minus 348. There's no other negative here, right? There's just this one, so it doesn't make it a positive. So it's 16 minus 348, and that's going to give me a negative 332 inside the square root. I can't take the square root of a negative number, so even though I could write my answer like this, it's really just no real solution because I can't take the square root of this negative number here. Okay? If I instead did completing the square, I'll erase this quickly to show completing the square. I would have gotten this. Okay, so I would start by leaving a space after this and moving the 84 to the other side if I wanted to do completing the square, and leaving a space on both sides for that. I would take half of this here, so half of 4 is 2, and I'm adding 2 squared to both sides, so this drops down and it becomes just k plus 2 squared. And on the right, I get negative 87 plus 2 squared, which is just 4. Okay, this is then k plus 2 squared equals negative 83. And I would take the square root of both sides at this point. But again, I have a square root of a negative here, so that tells me to stop because there's no real solutions. Okay, so that could have been another method to use here. Alright, and then moving on to 5 and 6, this is another graphing one, right? It's in vertex form. So we would identify the vertex, it's at negative 4, negative 1. And I would make my table here. This, if I plug in 1, if I go left or right 1 unit, 1 squared is 1, so I'm going up 2. If I plug in 1 squared is 1, and then I multiply it by this 2 here, so that's 2. And then if I go left or right 2 units, I'm plugging in 2 for x, so 2 squared is 4, times 2 is 8, so I get this. And my graph looks something roughly like this, so negative 4, negative 1 would be this point for the vertex. I know if I go left or right 1 unit, I'm going up 2, so that gives me these 2 points. And the other points are farther than that, but I can already see here a rough estimate of where I'm hitting the x-axis. So I don't want to just say negative 3 and negative 5 because those are these points on the graph, so I would probably want to give these a decimal approximation. This point I might say is about negative 3.3, and this point maybe is about negative 4.7. Okay. For number 6, we're going to start again just by moving the 5 over so we can really look at what we have. Okay, and again, there's no GCF. I can't do difference of squares or taking a square root because of this middle term here. So I could move forward. I could try Xbox. You wouldn't find any factors that way though, so I would do the quadratic formula. Completing the square here, that would be fine. You would want to move the 62 back over here. But in order to proceed with completing the square, you have to have a 1 in front of the x squared term, so you would have to divide everything by 5. And 5 doesn't go into 62 evenly, so that would involve fractions. So again, I'm just going to use quadratic formula here, which is this. And if I plug in the values for A, B, and C, I get x equals negative 20, so that's going to be just positive 20 plus or minus the square root of b squared, which would be 400, minus 4ac. A is 5, c is 62, all over 2a, which is 10. So x equals 20 plus or minus the square root of 400 minus 4 times 5 here is 20 times 62 would give me 1,240. And this square root here, I can already tell if I do that subtraction, I'm going to end up with a negative, specifically negative 840. Because I have the square root of a negative, I know there is no real solutions. Okay, so that is it for today's lesson. Go ahead and try the homework. Thank you. See you tomorrow.